So for this question, let's just start by drawing the scenario. So if one car is traveling south and another car is traveling west, then in terms of a triangle that we draw, we'd have a triangle moving out, or a line moving out to the west, and we'd have a line moving out to the south. And they would be connected by a diagonal here, and as you can see, there's a right triangle. And so our x would be here, our y would be here, and this would be our z. Okay, so if we have one traveling south at 60 miles an hour, then we can represent it with dx over dt equals 60. And then for the one traveling west, we can represent it dy over dt equals 25. We'll use equation z squared equals x squared plus y squared because this is a right triangle. And basically we're just going to find the derivative of them first. So to find the derivative, we would have 2z is equals to 2x plus 2y. And as you notice, the 2's cancel out here, leaving us with dz over dt is equals to 1 over z x dx over dt plus y dy over dt. Okay. And this 1 over z is from the cancellation process. So the next thing we're going to do is we're going to try to plug in the values, but first we need to find x and we need to find y. So we know that x corresponds with 60, and it wants us to find the rate 2 hours later. So we have to multiply 60 by 2 and 25 by 2, which gives us 120 for x, and it gives us 50 for y. So then we're going to use the equation z is equals to the square root of 120 squared plus 50 squared, and we're going to get 130. And with that, we're going to be able to find dz over dt, which would be equal to 1 over 130. And then basically we can plug these values back into this equation here to finally solve for the rate. And so when plugged back into the equation, you should get 1 over 30, which multiplied, or 1 over 130, which multiplied by 120 times 60 plus 50 times 25. And this should get you 65 miles per hour. And again, 120 times 60 would just be, and 50 times 25 would just be the values that we found here and here, and just multiplying them together. And overall, that's what we would get.